Hi, everyone, and welcome to the introduction to the Open RAN online course. So, whether you're a telecoms professional looking to upskill or just someone who's interested in the latest developments in telecommunications, this course has something for you. So, without further ado, let's dive into the world of Open RAN. So, let's first define what is RAN. So radio access network is a critical component of modern telecommunication systems. It's the part of the network that connects mobile devices like smartphones and tablets to the wider internet and other communication networks. The RAN is responsible for transmitting and receiving wireless signals, as well as managing the handoff of devices between different cells in the network as they move around. These cell sites are strategically placed across a geographic area to ensure that mobile devices within the network's coverage area can connect to the RAN and access network services. So you can see in this photo or in this slide that there are different types of mobile coverage. So in this example, you can see the island of Luzon, where you can see the different radio access technologies: 2G, 3G, 4G, and 5G. So this is an example or this is distribution of a coverage between different radio access technology. So in a wireless telecommunication system, the network is composed of three main parts. So you have let me have the laser point, okay? So we have the core network, we have the RAN or the radio access network, and then we have the user terminals, or for some engineers here, you can consider it as a user equipment or the UE, or for some layman people or for some lay people, you can say that it's a mobile device or a mobile station. So core network is the core network is responsible for managing the overall operation of the network. Um, it includes traffic routing between different networks and providing advanced services such as voice calling, messaging, and data services. So here, the RAN, on the other hand, is responsible for providing the wireless connectivity required for mobile devices to connect to the core network. So it includes a network of cell sites, each of which has a base station that communicates with mobile devices over the air. So you can see here the interface between the UEs or the user terminals via the air interface going to the RAN. So the RAN and the core network are connected by different means. So you can see here, if this is connected by the air interface, you can see that the RAN and the core network is connected via either the microwave. It's been the oldest interface been here for the wireless technology, and then we have the fiber optic, of course, and the satellite. Some, but in the Philippines, I'm not sure if we have this, but mostly we have the microwave and the fiber optic. So this is what we call the backhaul. So user terminals, also known as user equipment, as see here, are the devices used by end users to connect to the radio access network. So this is the phones, the mobile devices. So let's focus on the RAN because we're talking about Open RAN. So radio access network. The mobile network coverage comes from RAN. The RAN is responsible for providing the wireless connectivity required for mobile devices to connect to the core network. So, sabi nga kanina, it includes a network of cell sites. So, hindi lang siya isa. We have hundreds, thousands, depending on the geographical area. RAN is the part of the cellular network that is nearest to the subscriber. Because you can see it all around. It's the access point for our mobile devices. The location is widely distributed. So we can see it in the city, villages, highways, in the hills, beaches, and malls. And thousands of RAN elements create seamless coverage and mobility. The radio access network is strategically placed to provide wireless coverage to users within a specific geographic area, in this case, the Philippines, or let's see, here is the Luzon Island. Um, you can see that it's tracing the major routes and the major cities, major municipalities. You can see here the Cordillera Ranges, the Sierra Madre Ranges. Basically, we don't have coverage. So kung matenga ka dyan sa mga bundok, of course, you will be expecting that you will be having bad coverage, because from here you can see that there are no cell sites available. So the placement of RAN components such as the cell site is critical to ensure that users have reliable and consistent access to the network services they need. When planning the deployment of RAN, network operators consider various factors such as the population density, topography, building density, and the traffic patterns within coverage area. So basically, kung saan may mga tao, kung saan there would be a business case. Yun lang naman ang end goal of mobile network operators to translate this into business. So by analyzing these factors, network operators can determine the optical location and configuration of RAN components to ensure maximum coverage and capacity. So for example, in the urban areas with high population density and building density, network operators may need to deploy more cell sites. So in this case, you can see the high density of cell sites in the Metro Manila area, Greater Manila area, and some cities here. And then as you go up into the northern part or the mountain parts of Luzon, you can see that the density is going down. So in rural areas with lower population density, network operators may need to deploy fewer cells with higher output power to provide coverage to larger areas. So the placement of RAN components also affects the overall network performance, such as call quality, data speeds, and network capacity. So by strategically placing RAN components, network operators can optimize the network performance and ensure that users have high quality and reliable network experience. So you can see here some cell sites deployed for the whole of Luzon. So have you ever stopped to think about how your mobile device is able to connect to the internet and make calls and texts while you're on the go? It's all because of the radio access network. So next time you go out and about, take a look around and see these samples of towers or antennas that you can see by the roadside. You have in the provinces, in the mountains, even inside the malls. This is an example of an indoor solution. So if so happens that if you're in a mall and you can have a decent signal, most probably you don't have an indoor solution. And then some are street levels to provide street level coverage. So the RAN is what enables you to stream music or video or stay connected with family and friends no matter where you are, and it's not just limited to cities or towns. So as you can see here, it's all around us, and it's helping us to connect to the network. So can you imagine the time when mobile phones didn't exist? So let's talk about the evolution of mobile communication. So um, not long ago, communication on the go was limited to radio and landline telephones. It actually is not on the go per se because you're tied up with the fixed line. So that all changed with the introduction of 1G or the first generation mobile communication. So our design the convention here is that we have the generation the number of generation here, and then G stands for the generation. So the first generation, or 1G, was introduced in the 1980s. So it was the first mobile phone technology and used analog signals. So if you can remember, or if may mga umabot pa before, if you can remember those Bill Crusher and uh, yung malalaking phones, those are part of the 1G era. So these early mobile phones were large and expensive, and the network coverage was limited. But despite its limitation, 1G laid the foundation for the mobile revolution. So next came the 2G, or the second generation mobile communications, or the GSM. So before you only have a voice call, you only have voice, nakakatawag, tawag lang before. And it was supplemented by what you call, ano nga tawag doon, pagers. You have, kung may nakaabot pa with you the pagers, so for text-based communication, you have the pagers. So kung nakakaangat-angat ka sa buhay before, you'll have either you have the 1G phone and a pager or both. So that was before the 1990s. But the second generation mobile communication, introduced in the 1990s, enabled basic voice and text messaging services. And it's digital signaling. So 1G, analog, going digital, and we call it 2G. So it allowed for more efficient use of radio spectrum than the previous analog systems. Then came 3G, or third generation mobile communications. 3G was introduced in the 2000, and brought faster data speeds, enabling more advanced services like mobile internet, video calls, and multimedia messaging. So nakakapag medyo mas bumuka na yung bandwidth niya, so that you can have more value-added services. Before, it's just text messages or SMS. Now you have MMS, if you can remember it before. So mas glorified messaging before. You have the pictures and you have videos, GIFs, with the messages, and you have the video calls. Actually, when it was introduced in the Philippines, people are looking forward for a killer application like SMS, but which is a video call. Pero parang hindi ata nag take off because uh, there are more applications that provides more um, functionalities than the video call. But yeah, the 3G, the coming of the 3G introduces us to the video calls. So next was 4G. Okay? So before we're making calls, hindi natin nakikita yung mga tao, then we added messaging because bumubuka na yung bandwidth natin. You can add more services like text-based messaging. And then when 3G came, we can have like video. You can see people now, and you can add more flair to the messages via MMS. Now, when 4G came, or the fourth generation mobile communication, this is around 2010, it brought even faster data speeds, better network capacity, and more reliable coverage. So 4G enabled advanced services like streaming, video, online gaming, and mobile payments, and paved the way for the Internet of Things. So you can have like those edge devices that you can control via the internet. And now we're in the era of 5G, or around 2020s, or the fifth generation mobile communication that promises to be even faster and more capable than 4G, with data speeds that are up to 100 times faster than 4G. So 5G is expected to enable new and innovative services, like augmented reality, autonomous vehicles, yeah, the V2X, those things, and smart cities, and to transform the way we live and work. So there you have it. So you can see it, the evolution and the improvement in the mobile communication. So before, you have this uh, services, and here in the 5G we'll be discussing it maybe later. But yeah, we can have what I said before, smart cities and autonomous vehicles. So we have more data capacity now than ever before. So let's go into some of you might have been uh, immersed into this, but for those that are not yet familiar, or not conversant with this, so let's talk about the complex system of components that work together to provide wireless coverage and connectivity to mobile devices. So first, there's the tower structure. Okay, this is the physical structure that supports the RAN components. So such as the antennas and the cables. The tower structure is designed to be sturdy and stable. So it's more on the purview of the civil engineer, but this is part of the radio access network. And right now in the Philippines, but it's been practiced in other countries. But in the Philippines, we're now having common towers. So before, it's part of the uh, total cost of ownership for the MNOs or the mobile network operators. But now it's been uh, distributed to some third parties to have the common tower arrangements. And then next, there's the antenna system. The antenna system is responsible for transmitting and receiving radio signals between mobile devices and the RAN components. So the antenna system is typically made up of multiple antennas that are placed at different heights on the tower structure to provide coverage to different areas. So basically, we can say that antennas are like um, what you call that flashlights. So it's being directed to the user terminals so that you can access the radio access network. Okay, then the next would be uh, radio remote unit. So a critical component also of the RAN. It is responsible for converting the radio signals um, received by the antenna. Okay, so the R is typically located at the top of the tower structure near the antenna system. But this is, I mean, a new implementation because I remember before that some RRUs are in the what we call this cabinets under the tower. But now, to make it more efficient, radio remote units are now on top of the tower together with the antenna. Okay, remote units, and then next would be the cables. So this one is the one connecting the different components. So the antenna going to the radio remote unit, and then the going to the next one is the baseband unit. So the BBU or baseband unit is another critical component of the RAN system. So let's think about these things like a computer. So this one, the baseband unit, is the one responsible for processing the digital signals received from the RRU and transmitting them to the core network. So pabalik. Pero pag nag-send naman siya palabas, it's going to the RRU. So the digital signals is converted to the radio signals going out of the antenna system. So and then this one is a CPRI. So it's the one is the interface standard protocol to transmit the digital signals between the RRU and the baseband unit. So these are important later on when we discuss further about the Open RAN. So actually marami pang ibang dapat i-discuss, but basically we'll just have to focus on this components. Then you have here the cabinets. Then you have the microwave antenna going to the core network. Yep. If you can remember this, the backhaul going to the core network. So to give you a view of the remote unit, this is an example of the remote unit under the antenna. You can see here the uh, antenna here and the radio remote unit or the RRU. Then you have the outdoor cabinet here with the baseband unit here. So RRU is a radio transmitter that communicates with mobile devices over the airwaves and is located remotely from the baseband processing unit. And then you have the baseband unit. So yun nga, it's responsible for processing the baseband signals. Okay. And then you have the CPRI, or basically is the front hall connecting the RU and the baseband unit uh, for high-speed transmission over the fiber optic cables. So the evolution of radio access network, for currently we have the traditional network, wherein we have, of course, we have the core network, we have the baseband, and we have the radio unit. So the evolution of the RAN architecture has been driven by the need for more flexible, scalable, and cost-effective solutions to support the growing demand for mobile data services. So here you have the traditional network, or basically this is a distributed RAN, wherein the baseband and the radio units are in the cell site premises. So currently, this is the one we're having, at least here in the Philippines. So it's non-split. RU and BBU are co-located on site. Um, uh, RU BBU connected by CPRI, and the BBU, the baseband unit, the RU, and the interface are proprietary, including hardware and software. So you can't you can't have a different you can't have different vendors for this one. So if you have chosen one vendor, you have to have the whole radio access network to be one vendor only. And then you have the centralized network. So to have an efficient implementation, actually is an architecture that emerged in response to the need for flexible and cost-effective solution. So if you can see here, you still have the core network, still have the baseband, and you still have the radio unit. The difference is that the baseband, the BBU, the baseband unit, is in the central office, so away from the cell site. So ang naiwan lang on the cell site premises are the RUs, the radio unit. So your front hall going to the baseband pool in the central office are now centralized. So here you can see that site only has antennas and RU, but still the BBU, the RU, and the interfaces are proprietary to a vendor. So that includes the hardware and software. You cannot have a hardware of a different vendor and then the software of a different vendor. So if pag binili mo siya, bundle siya, hardware and software for one vendor. And then you have now a virtualized network. Okay. So still have the core network and the radio unit, but the baseband unit functions are virtualized and run on COT, or what we call the commercial off the shelf. So if we are familiar with cloudification, um, uh, you're virtualizing the functions of one part of the system. So in this case, it's the baseband unit. So it use a software-defined networking and network function virtualization technologies. So you can see here proprietary software and virtualized functions. So still proprietary, but we're there. I mean, um, we have actually minimized the cost because we're now using commercial off the shelf. It means that you can buy a white box, or yung bang it will not, you don't have to customize it. You can just buy any um brand and then have the virtualized, or the virtualized function run on the COTS. So, but still, it's proprietary. The software and the visualized, with the visualized function, and the interfaces still proprietary, and comes the Open RAN. So it actually taking a cue from the virtualized network, or the VRAN, but the thing is, it's cloud native now. Can be in cloud native, the network function, and then you have the general hardware, general purpose, And then instead of proprietary interfaces, you have open interfaces. So RRU and BBU is COTS based hardware. So you can have a different brand on the hardware and then can have a different software also. BBU functions are virtualized. Front hall is open interface, like in this diagram. And then disaggregated multi-vendor interoperable hardware and software are now being deployed here. So you can see here the actually it's the evolution of radio access network. In the Philippines setting, we're still on the traditional network, and because it will also entail costs if you're going by this evolution. So this is just some of the networks outside the Philippines are now employing some of this. Um, and then we have introduced Open RAN to have it to have the interfaces and the hardware software open. So later we will discuss it. So traditional RAN, vRAN, Open RAN. So these are the differences. As a summary, you can see here that you have the baseband, you have the antennas, and then you have the RRUs. But the thing is, in traditional RAN, you have the closed CPRI, you have the closed front hall, you have closed back hall, and then you have closed CPRI and mid hall also for the virtualized RAN. And then taking cue from the virtualized RAN, we have the open RAN and the interface is open. So these are the differences for the traditional, virtualized, and the open RAN. So Open RAN is actually a hot topic in mobile telecoms now. So the ambition for Open RAN is to create a multi-supplier RAN solution that allows the separation between hardware and software with open interfaces. In other industry also, there is what they call this, an effort to have the total cost of ownership for assets to go down. Mas piliin ko na hindi muna maglabas ng malaking pera for the capital for these assets. So what other companies are doing are parang pinapaubayan na lang with some um, uh, cloud companies to have their functions virtualized into the cloud. So even before there's an incentive to disaggregate their different networks, and radio access network for mobile network operators are not far behind. I mean, uh, that is the ambition of the Open RAN. Okay, to disaggregate the network so that we can create a multi-supplier RAN solution. So you can see here that they are open challengers. I mean, yeah, new challengers to the open market. So before we can have two, three, four companies that can be in the space or in the industry. But now, if you evolve towards the Open RAN, we can have these other partners, other companies to take part, and there would be more collaborations for those companies that had at stake in the industry. So now let's answer the question: what is Open RAN with all those um, uh, history and all those technologies that was discussed before? um, we can see that the key challenges for telco operators are faster time to market, better performance, and lower cost. You can see here that faster time to market means that faster rollout for new features, services, and capabilities. Kaya nga may mga agile tayo now, right? So that um, we can have it fast and efficient, Yung hindi kailangan magtagal. Dapat pag sinabi, gawin natin 'to, you have the flexibility, you have the agility to do it. So that parang kumita agad. I mean, you have to deploy it in production. So, of course, you have to have significant investment in new technologies. So ang tanong is what technology to use. Now, better for performance, expand and improve system capacities. Now, to have better coverage and enhance quality of service. So, and then with all of this improvement, of course, ang last say, for example, for the board or for the owners, is the cost, of course. So to cut in energy consumption, so to lower the equipment costs and to reduce the capital and the operating expenses. These are the challenges that the telco operators must undertake. So in the current traditional RAN, we can see that in data in quarter one of 2021, we can see that these are the major players or in the space. And you can see the percentage of market shares coming from these one, two, three, four, five vendors. So they can see here that the current RAN implementations offered by incumbent vendors combine the equipment in an inseparable linked set of proprietary hardware and software components. It means na if one company like Huawei get a project for operator, matatali sila with that project for several years. So because if you use the hardware for the radio access network, you have to use the software and of course the services can be outsourced, but basically the hardware and the software they cannot disaggregate because it's a monolithic system. So ang unang tanong lang is sino makakauna, and if one of these bags a project, it would take several years before they can swap out. And so pag napili na yan, so tali ka na for the next 5 to 7 years, 5 to 10 years. So because they are proprietary hardware and software. So yun nga, it creates vendor lock-in, it fosters dependencies, less and fewer vendors. So because it's monolithic, you tali ka sa isang single vendor. Now, the principles of Open RAN is to have it disaggregated. So Open RAN is the manifestation of broader technology move called disaggregation, what I've said before. So in the IT space, disaggregation is a thing na. Kaya nga meron ka mga AWS, you have the Google Cloud, you have the Azure, because companies are now looking to cloudify or to virtualize the functions. So instead na the servers, the assets are mine, ano ko na lang, i-virtualize ko na so that the TCO or the total cost of ownership would or the capital expenses would go down, and the operating cost also goes down. So disaggregation is the splitting of the system into smaller subsystem. And disaggregation means that the separation of the hardware and software are there. So we can have a hardware from one vendor. Actually, in the hardware, you can have different vendors also, because since it's open, so parang plug and play yan eh. You know, like in a computer, you can buy different mouse, different monitors, different keyboards because they are open. I mean, hindi ka matatali sa isang product, sa isang vendor or sa isang brand. So that's what's disaggregation. So for Open RAN, we focus on the disaggregation of the radio access network components, which is, of course, the RRU, the baseband unit, the front hall, the back hall. You open natin lahat. But actually, there's also discussion on the core network, but that would not be part of this course. But it's part of the Oran Alliance also. So later, Richard would maybe discuss about it, but in passing. But now we're focusing on the RAN. Okay. So Open RAN is a disaggregated RAN. So you have here the core network. and then you have the traditional RAN, and then we want to evolve. Okay, that's what this movement is about. The evolve the traditional RAN. Um, actually, even before the open RAN, there's a discussion um, to have only on that efficiency. Kasi nga, if you go back a while ago, you have the traditional RAN, and then you have the centralized RAN. So wherein you take away the baseband unit and put it in the central office, but we go further and have it virtualized. But all of these are all proprietary. So, but the goal is going um, uh, to before it's going to virtualization, but they went further and go on disaggregation so that you have it uh, the interfaces and the hardware, the software open. So you can see here, you have the open front hall, you have the open interfaces, open hardware and software, and then this special um, function here, or special block here called the what do you call this? The RIC, which will be discussed in detail in the succeeding discussions. But this basically the one orchestrating or controlling or having uh, the seamless operation of the Open RAN. Uh, when we go into disaggregated radio access network. So what does open mean? So ba't tinawag na open? Yun nga, the main goal for this is using Open RAN to have an interoperable standard for RAN elements. So open refers to the intentional capability of the software, the hardware, and or interfaces to comply with the agreed upon standard. So like what I said, we have an open software, we have an open source hardware, and an open interface. So Open RAN is Open Radio Access Network as an industry movement that develops this aggregated and interoperable radio access solution, leveraging on the general purpose processor hardware, software defined technologies, and open interfaces based on industry standard.